Let's go.
And now to present today's speaker, Rob Beresford. Rob, take it away.
Thanks very much, Jenny. So my talk today is going to be about a project that we've been running with, funded by the Ministry for Primary Industries, and it's a series of field trials that we've been doing on alternatives to synthetic fungicides for metal rust control. And I'd just like to acknowledge my co-workers, Peter Wright at Plant and Food Research in Pukekohe, who's been running these field trials for us, and also Tony Roglinski, and he's provided a number of new alternative products for us to test in the field trials from glasshouse screening that he's been doing at Ruakura. Metal rust was first found in Aotearoa, New Zealand in 2017. It is now widespread throughout Te Ika-a-Maui, North Island, and the upper Te Waipanumu, South Island. It threatens several of our native species, and 4 in particular: Mairi tawaki, which is swamp mairi, Syzygium mairi is the botanical name, Ramarama, Lophomyrtus pullata, Rohutu, Lophomyrtus obcordata, and Pukekohe, Metrosideros excelsa. Those 4 are very severely impacted, and well, Pukekohe less so, but the other 3 are certainly very severely impacted by metal rust. Now, we know that conventional synthetic fungicides can control metal rust in a wide range of settings. For example, to allow flowering, fruiting and seed collection for conservation of severely impacted Mairi tawaki trees. And the photograph on the right there shows part of a stand of trees at Bush Glen Reserve on Auckland's North Shore. The trees are very severely impacted. You can see there's hardly any crown left, only a few leaves on the tops of the trees. But the branch in the foreground has been sprayed from the ground with fungicides on a regular basis. And that's allowed us to actually allow the trees to flower and for us to collect fruit from them and actually raise seedlings from them. It's been very successful. However, not everybody wants to use synthetic fungicides because of perceptions about negative health and environmental effects. Alternative products to synthetics like baking soda, sodium bicarbonate, are being used in some plant nurseries, but there is a lack of empirical evidence that this and any other products actually work. The project MPI funded to investigate alternatives to synthetics included laboratory and glasshouse screening and field testing of selected materials. The project is just finishing actually, and MPI's final review will be complete in April 2025. Fortunately, we were able to share the interim findings from the field trials now. So we ran 5 outdoor trials between 2022 and 2025, and we compared 16 alternative fungicide products with synthetic fungicides and water-sprayed control treatments. The trials were done at Pukekohe Research Station, Plant and Food. Potted plants of the susceptible native Lophomyrtus red dragon, and that's a named cultivar, but it's a natural hybrid of Lophomyrtus pullata and Lophomyrtus obcordata. The plants were grown from cuttings, so they were clonal and very genetically uniform. Each trial had between 9 and 11 treatments, randomized within each of 9 replicated blocks. You can see that on the photograph on the right. The experiments relied on natural infection by metal rust spores, and a severe metal rust epidemic developed in each trial over a 2 to 3 month period. So there's important considerations for testing alternative products. There's 2 things of particular interest. Obviously, firstly, there's efficacy in controlling metal rust, but the second one is plant damage due to toxicity of the applied products. We call this phytotoxicity. It's a very important consideration for a lot of the alternatives. Now, while some synthetic fungicides have curative or systemic activity through being absorbed into the plant, alternative products generally have only protective activity. Therefore, the treatment applications in the trials were initiated before rust infection became established, and each trial received 4 to 6 product applications at about 2-week intervals. So over a 2 to 3 month period, each trial was run. We measured a number of variables on the treated plants in the trials. Firstly, percentage of shoots infected, and that was determined by the presence of spore pustules, initially yellow and later turning white or grey as the metal rust lesions aged. And secondly, percentage of shoots with the shoot tip dieback. Now, the dieback developed later in each trial as spore load increased during repeated infection cycles. And obviously, the dieback is a very debilitating symptom for the trees because it kills the growing shoots. Then the third thing we measured was the percentage of shoots with new growth flush. This was used in conjunction with shoot infection and shoot dieback to identify treatments that caused phytotoxicity. I'm not going to go through and show you all the results from all the trials. That would take all day. So I'm just going to show you an example from one of the trials which illustrates the way that these variables we measured manifest in terms of the data we collect and how we can interpret what was going on with myrtle rust control and phytotoxicity from those variables. So firstly, we've got percentage of shoots infected for one of the trials, and you can see that we've got the percentage of shoots on the vertical y-axis and then 11 product treatments along the x-axis on the bottom. Firstly, we've got copper oxide on the left and 4 synthetic fungicides, which gave significant protection against infection. Sodium bicarbonate, you can see at 5% also gave very good protection. I'll come back to that in a second. 4 alternative products were no better than the water control there on the far right-hand side. Sodium bicarbonate at 5% rate appeared to give significant protection, but not at the 1% rate. Now, the little letters on the tops of the bars going along there indicate the statistical significance of the differences between the various treatments. So you can see there's a whole lot of A's here, including the carbendas in there, which are not significantly different from each other, although there seems to be a bit of a trend going on within there. And then the C's are not significantly different from each other, and the B's are not significantly different from each other. So going on now to percentage of shoots with dieback, we can see here that the sodium bicarbonate caused a very severe dieback at 5% and some dieback at 1%. So the application rate is obviously making a big difference to the amount of dieback there. Here's the water control is on the second from the right, and you can see that the sodium bicarbonate is actually significantly worse than the water control. Potassium silicate, one of the things we tested here, was no better than the water control also. But the 5 synthetic fungicides and copper oxide gave significant protection against dieback. And now moving on to percentage of shoots with new flush from this trial. Once again, we can see that the sodium bicarbonate at a 5% rate significantly suppressed growth. It was very phytotoxic, significantly worse than the water control. The growth flush suppression caused by myrtle rust is shown by the water control value there, and you can see that 1% sodium bicarbonate was causing quite a lot of growth suppression here, as well as the 5%. But the other products gave varying amounts of growth suppression, with the synthetic fungicides on the left, towards the left, doing the best. So in terms of interpreting the alternative product performance in the trials, there's a very important point about myrtle rust. That is, the active growth is required for myrtle rust to infect shoots. So if there's no growth, you get no disease. And that's a fundamental truth about myrtle rust wherever you see it in the native estate or anywhere. If a plant isn't growing, it won't get infected by myrtle rust. So a phytotoxic product that suppresses growth but has no direct efficacy against myrtle rust may lead to very little disease because there's no growth to be infected. However, the growth suppression means the product is of no use. So that's an important thing with these trials, that a number of the products weren't effective at controlling disease, but they did actually suppress growth substantially, and actually sometimes there was very little disease in products which actually had no efficacy. So interpreting alternative product performance is more difficult than for high efficacy synthetic fungicides that have been through the ACVM registration process. And I'll come back to ACVM and explain it in detail a little later. But in that process, phytotoxicity is identified during product evaluation. Now, just looking at all the products that we tested over all the trials. So this table here shows that there were 23 different products, and we rated them across the trials using a semi-subjective rating between 1 and 10, separately for myrtle rust efficacy and for tendency to cause plant damage and phytotoxicity. So the green is the best performance, high efficacy, low plant damage, and red is the worst performance, low efficacy and high plant damage. The alternatives to the synthetics have got the blue bar beside them, and the 7 at the top are synthetic fungicides. Now, those synthetic fungicides include a number of single site inhibitors. Those are the ones which have very specific mode of action, and those are the ones that are at risk of resistance development if they're used too often. We also had a multi-site inhibitors of the synthetic fungicides, something like mancozeb, which is only protective, but still a synthetic fungicide. And then we've got 5 copper and sulphur fungicides, inorganic materials, copper oxide, copper oxychloride, copper hydroxide, and sulphur, elemental sulphur, and lime sulphur, which is a widely used product in horticulture. We've got 2 chitosans. Those are sugars derived from fungal cell walls. They're compounds that have high bioactivity. They're also used sometimes in human medicine. So we trialed those. 2 plant oils, rosemary oil and aniseed oil, and 2 biological commercial products based on Bacillus subtilis. Those were Bacstar and Serenade Optimum. So those are commercially available products. We looked at 2 bicarbonates, sodium bicarbonate and potassium bicarbonate, and then some other ones, potassium soap, potassium silicate, and sea salt. So of those products, the chitosans, the plant oils and biologicals were from the glasshouse screening at Ruakura. So looking at the performance ratings, we categorised them into categories A to D. The category A, the green, was the high efficacy with negligible plant damage. B has slight efficacy and slight risk of damage. C, low efficacy, moderate risk of damage. And D, negligible efficacy and high risk of damage. In terms of where the different products that we tested fitted, so for category A, first of all, the synthetic fungicides with high efficacy, single site inhibitors were better than the multi-site inhibitors. And of those, triadimenol and trifloxystrobin are the best synthetics we've tested so far. The products that we've been using of those for the swamp miry work are Pandia for the triadimenol and Flint for trifloxystrobin. Then there are the category A alternatives to synthetics, which are the copper products and the sulphur, excellent protectants. The coppers, however, have strong negative environmental effects, and sulphur is slightly more benign than the copper compounds in that regard. In category B of the alternatives, slight efficacy, the chitosans, plant oils, and biologicals, Bacstar being a little better than Serenade Optimum, and lime sulphur. So those category Bs have some promise, I think, for myrtle rust control in the field. Category C and D, low or negligible efficacy. Sodium bicarbonate, baking soda, fitted in there. It has weak efficacy. It gives variable results and is prone to causing plant damage at fungicidal application rates. Potassium bicarbonate is similar to sodium bicarbonate in efficacy and phytotoxicity. The potassium soap, the potassium silicate, and sea salt appear to be of no use for myrtle rust control. So now I'm going to turn to the government regulations around plant protection products, because this is really important to understand when we're using things either registered or not registered. ACVM registration by the Agricultural Compounds and Veterinary Medicines Group of MPI. For products used in food crops, ACVM registration checks the efficacy, plant safety, residues, chemistry, manufacturing, and product quality to make sure the product does what it says it will do on the label. Very reassuring to know that this is going on with these compounds. no products are actually ACVM registered for use against myrtle rust in New Zealand. So none of the products have got label claims for myrtle rust. However, many ACVM registered products can be used for controlling myrtle rust under off-label use conditions. And I've got a website reference there where you can look up what ACVM, what off-label use conditions are. But with that, although you can use them for myrtle rust, the user is responsible for managing any risks, including residues and environmental considerations, and there may be other risks as well. So which of the tested products are ACVM registered? So we've got all of the synthetics are. We've got a column down here now in the middle there showing the ACVM registered ones with a tick. All the synthetics are ACVM registered. The copper fungicides, sulphur and lime sulphur, they're ACVM registered. The two biologicals are Bacstar and Serenade Optimum, so that means that the chitosans and plant oils are not ACVM registered. Potassium bicarbonate is registered, but sodium bicarbonate is not. And then potassium soap and potassium silicate are both registered, but they're not of much interest because they don't work. So what about the non-registered products? We've got those ones. Well, these are exempt from ACVM registration if they are not used on plants used for food production. But again, the user is responsible for managing any risks. So we can actually use these non-registered ones so long as they're not used on food products. Non-ACVM registered products cannot be used on feed jar or manuka for honey or any other myrtle plant used for food production. I think for our conservation work, we're not in any risk of using them for the wrong purpose there. Now, users of any of these products should also check the Hazardous Substances and New Organisms Act 1996, administered by the Environmental Protection Authority, that's EPA, for any additional controls on any of the materials used. From time to time, EPA puts special additional controls. It might be the number of applications that can be used per year or where or how they can be sprayed. So that information needs to be checked as well. So for the chitosan and plant oils, which looked quite promising in our trials, further research is required to develop usable formulations for those and possibly obtain ACVM registration, particularly for the chitosans. And now, in terms of finding registered products in the public ACVM register, it's actually very easy to do. You go to the website there. Comes up with the screen. Sometimes the screen doesn't work if you put in an active ingredient or some product that you want to look up. I've put in potassium bicarbonate there in this case. Sometimes it doesn't work, but you just have to go over to the where it says ACVM register, the grey box on the left, and click there, and then it will work for you. So you put in a search, either it can be a registration number, or a trade name, or a product type, or somebody that, or a registrant that's registered a product. In this case, I'll put in the active ingredient, and it comes up with a list, complete list of registered products that have that active ingredient in them. In this case, it's 7 different potassium bicarbonate products. And you can go to the actions on the right-hand side. You can see the registered label for each product under the view there, and the safety data sheet. So you've got all the information that you would ever need to know about whether you're using these products responsibly. Now, in terms of using alternative products, there are a number of things I think that we really need to be careful of. Always test an alternative product first on a few plants to observe whether there's phytotoxicity. An example of that is a swamp myri tree I have growing at my place, and I suspect it may be sensitive to sodium bicarbonate, which I did try spraying about a year ago. When I sprayed the sodium bicarbonate, after that, the tree has, since then, the tree stopped growing. And it actually looks like it's waning and dying at the moment. Now, swamp myri trees are prone to do that. This tree's had no myrtle rust on it because I had previously sprayed it with synthetic fungicides. So it may be sensitive to phytotoxicity from sodium bicarbonate. Now, another thing is it's possible rust control efficacy could be improved by mixing products together. However, alternative products may not be chemically compatible with some conventional fungicides, and incompatibility could affect efficacy and risk plant damage. Again, a reason for doing a trial on a few plants before you launch into using alternative products. Alternative products, as well as many synthetic fungicides, have only protectant activity, which means applications in the spray program should begin before infection has become apparent. And for the work that we do in conservation, a very useful tool is the publicly available weather risk tool on the New Zealand Plant Producers website that identifies high-risk periods for myrtle rust to help manage fungicide sprays. And there's a link that takes you there, and you can actually use that tool to monitor the weather risk over the season, and it actually allows you to put in fungicide sprays, and it suggests when you might put on the next spray. So then briefly in summary, the alternative products can be used on myrtle plants not grown for food production, either ACVM registered or not ACVM registered. Copper fungicides and sulphur give a high degree of protection with low risk of phytotoxicity when used at label application rates. Chitosans and plant oils tested show slight efficacy, but work is required to develop usable formulations, so they're not currently available for general use. Lime sulphur has similar efficacy to the chitosans, but is less effective than sulphur. The sodium bicarbonate and baking soda, the potassium bicarbonate is ACVM registered, have weak efficacy. They may be useful in low risk situations. They have low human and environmental toxicity, but do tend to have plant toxicity. So I'd just like to acknowledge the Ministry for Primary Industries for the operational research funding for the project we've just completed. Also the Environmental Protection Agency for approval to test the non-registered products. And Stephen Hoyt, particularly at Plant and Food Research at Ruakura, for managing the supply of the clonally propagated Lophomyrtus plants. And to finish off with, I've got a disclaimer from Plant and Food Research, which I will not read out. So thank you very much.
Thank you so much, Rob. I am so excited that there are alternatives to synthetic fungicides, and I think a lot of people are interested in this talk because of that. We have some questions coming in on the chat, but I wanted to start with a question that you kind of addressed at the end, but would any of these alternatives work as preventative measures?
Well, only the ones I mentioned really. So the group Bs, which are the chitosans and the biologicals. The biologicals are available for use because they're registered compounds.
Okay. And then another question's come in. What's the mode of action of these treatments? Inhibiting spore germination, chitosans may also prime defenses.
Yeah, yes, we really don't know for the alternatives because no one's done any research on it, but there will certainly be inhibiting spore germination. The things like sodium bicarbonate, potassium bicarbonate, it's probably through high pH, so they alter the pH of the leaf surface, and that can inhibit spore germination. But there may well be plant defense activity amongst some of the things as well. Particularly perhaps the chitosans.
Okay. And then would you prefer to use synthetic fungicides or alternative fungicides?
Yeah, it's a really good one. I don't like spraying. If you're going to be spraying alternatives, you're going to have to do it twice as often, at least twice as often, to get the same effect. Yeah, so my personal preference would generally be to use to use synthetics, but there's a lot of people that don't think that way, and so the alternatives are really important.
Great. Could the efficacy of some alternatives be improved by the inclusion of adjuvants in the spray formulation?
Yes, we did add an adjuvant, a wetter to all of the treatments in the trials. So that was uniform across all the treatments. ActiWet was the one we used. But there are other adjuvants that can be used, and it's very likely that you'll get improvements in performance through doing some research on adjuvants. Yeah.
Right. And then was wondering what the next steps are for this project. Nursery scale testing of a limited number of treatments, question mark?
The nurseries are, some nurseries are already using a number of these products, well, particularly baking soda. So in terms of a formal project, there is nothing on the horizon there. The information is out there now. And although further development work is required, if, for example, the gaining registration for chitosans, that would be really on plant and food research to take that forward from here.
And then is there a resistance developing to all control measures due to continued use?
Well, the synthetics, that's a big risk, and we take resistance management actions to try and prevent that by basically rotating different products. For the alternatives, we don't know. Some of those alternatives, the biologicals particularly, often have a antibiotic mode of action, and it's conceivable that you could get resistance over time to those. So the other ones, just the general protectants, things like the chitosans and the sodium bicarbonates and so on, probably I think the resistance risk for those would be low.
All right. And then one final question. Where are you coming from today?
Where am I coming from today? Yes, I didn't say, did I? I'm coming from the Pest-Free Kaipatiki Swamp Mire Conservation meeting that's on Auckland's North Shore.
Thanks. Are you gonna be participating in more? Are you giving more talks with them today on other things?
We're having a discussion for the discussion in the early part of the morning was really around propagating swamp mire seedlings. We've collected a lot of seeds from trees that have been sprayed with fungicides this last season, been very, very successful. And so we're talking about how to raise these tricky little seedlings because they don't grow very easily.
Yeah.
And they also get myrtle rust very readily.
Yeah. It's been noted that there's been more flowering this season than in previous years. Have others noticed this? And is this true for all myrtles or just this one?
Certainly seems to be true for this one. I can't speak about other myrtles. Maybe I've got some rama in the garden at home. They've flowered very well this year as well, actually. So, yep, no, curious thing. It's been a very dry season. So a lot of the swamps around Auckland, where the swamp mire trees are, have dried out. We've got very dry swamps this year. So we hope there'll be some rain soon because that might be a danger for the trees.
Yeah, for sure. All right, well, that's it for today. Thanks again, Rob, for your presentation. It was fantastic. A video of today's webinar will be made available on the Beyond Myrtle Rust YouTube channel in the next couple of days. It will be sent around to everyone who registered, but on the YouTube channel, you can also watch all the previous webinars we've had. We are still nailing down our next speaker, but you can expect an invite for the next webinar in early April. And make sure you've marked the dates for the Australasian Myrtle Rust Conference. That is the 16th and 17th of June. We'll be sending around information regarding virtual attendance sometime next month. Thanks everyone, harera, and see you next time.